Good day, everyone. I am Roy Spinida, and I am the leader of Group 5. We were tasked to present about other geographical hazards, starting with bolide impact. So first, let's define what is a bolide. A bolide is what we call to an extraterrestrial object. Bolide impacts apparently happen less frequently and less likely to occur, that is, compared to other geographical hazards and natural disasters. However, this may pose one of the largest or greatest threats to the existence of human race. Since a comet or asteroid impact 66 million years ago is being looked as the most probable cause of extinction of the dinosaurs and 75% of animal and plant species. The asteroid impact left evidences similar to the figure. Well, the effects of bolide impact may include large worldwide eruptions, tsunamis, wildfires, and drastic change in climatic conditions. But what on earth are impact events? When an asteroid, meteor, or meteorite hits the Earth's surface, the portion of the ground which is hit becomes extremely compressed and deformed, as shown in the figure. Instantaneously, rock fragments from the impact site, which is called ejecta, hurl into atmosphere and eventually falls down to a round bowl-shaped depression surrounded by a raised rim. The depression created by the impactor is called impact crater. Deadly impacts are caused by larger extraterrestrial objects, which thankfully happens less frequently. Very small meteorites called micrometeorites ranging from 50 micrometers to 2 millimeters in average diameter hits the Earth in very frequently and produces deposit worldwide on a daily basis. So let's now figure out the relationship between the size and frequency of impact. Let's look at the table below. As you can see, the smaller the extraterrestrial object or a bolide is, the higher the frequency or the higher the times where it enters the Earth's atmosphere, while the larger the bolides or extraterrestrial object, the less likely for it to enter the Earth's atmosphere. So now, let's give the mic to Daniel Peñero to explain asteroid, comets, meteorites, and their difference.
I will share with you the differences between extraterrestrial materials. First is asteroid. Asteroids are large stone or metallic rocks which are confined in the asteroid belt. Comets are a combination of ice, rock fragments, dust, and are found on Oort cloud. While meteoroid, and meteorites have almost the same characteristics, but the difference are its location. They are stony iron chunks, but meteoroids are located in the asteroid belt, while when it reach the Earth's atmosphere, it is now called meteoroids, and when it hit or landed on the Earth's surface, it will be called meteorite or as meteorites. We can see here in the illustration that the four planets or four inner planets are surrounded by many extraterrestrial materials, because these four planets are inside the asteroid belt, and this means that on any given time, many extraterrestrial materials can go inside and hit these 4 planets. We will use the moon as an example on how dangerous it is on being hit by an extraterrestrial material or materials. The moon, which has a thinner and less stable atmosphere, allows entry of extraterrestrial material and promotes preservation of impact craters. This is why there are more observable impact craters on the moon than the Earth. So we are lucky enough to have a thicker and stable atmosphere, and it doesn't allow any extraterrestrial material to go inside the Earth. Evidence of past impacts. Questions regarding the size of the impactor, exact location of impact, speed, and angle of approach of the impactor, and so much more can be answered by thorough study of remnants of events. I am now going to share with you the potential effects of bolide impact or large impact events. These are drastic change in climatic condition, wildfires, tsunamis, and acid rain. Drastic change in climatic conditions may happen when prolonged suspension of dust in the atmosphere coming from the disturbed rock may prevent insolation and cause an impact winter, while wildfires may happen when radiation of the intense heat generated as the bolide travels through the atmosphere. The smoke from such wildfires can add to the dust which are already preventing the insolation. Tsunamis may happen when a large impact takes place in the ocean, and it is expected to have a 1 to 3 kilometers high tsunamis when a bolide impact hit the earth and the ocean. Acid rain could result from the contamination of water vapor in the clouds by nitrogen oxides. Nitrogen and oxygen in the atmosphere are combined during the shock created by the impact.
Thank you, Daniel. Now, let's hear from John Carlos Carito to explain about our next topic, ground subsidence.
Next is ground subsidence. Ground subsidence is the relative lowering of the Earth's surface, usually with respect to the mean sea level. It can be a result of any of the following: dissolution and collapse of limestone, excessive groundwater withdrawal, mining, oil and gas extraction, earthquakes, and change of season. Causes of ground subsidence. First, carbonate dissolution and collapse. This is a common cause of subsidence, especially in the Philippines, which has an abundance of limestone terrains due to its geographic setting and extensive coastlines. Underground voids, ranging from small caves to extensive cavern networks, can be created in areas where limestone is the predominant rock type, meaning carbonate dissolution occurs in places where there are carbonate rocks such as the limestone, and this can lead to occurrence of caves in the ground or even sinkholes. Second, excessive groundwater withdrawal, also a main cause of subsidence in the Philippines, particularly in the Kamanava area of Metro Manila and in a lot of other highly populated urban centers in developing countries worldwide. The pressure of the fluids filling up voids in permeable sedimentary rocks support the overlaying rock layers and the ground surface. Shown in a picture, in the upper part is the natural ground and also the well. Below it is the potential settlement area. And below the potential settlement area is the water-bearing sands. In the description it says, if sands are overpumped and can't recharge as fast as they are pumped, the clays will compact and the ground will settle, meaning the use of excessive groundwater, which is collected in the well, as shown in the picture, can cause the land to deform, leading to a major impact to the environment. Third, extraction of oil and natural gas. The withdrawal of these fluids is mainly anthropogenic, or in other words, human activities, but can also be caused by natural processes such as by outflow through springs. Fourth, earthquakes. Aside from the relative subsidence measured on the hanging wall of a normal fault or the footwall of a truss or reverse fault, another situation in which ground subsidence may occur is during liquefaction, which takes place in areas with fine-grained sediments or areas that were reclaimed. Fifth, isostatic rebound. The Earth's crust, which is floating on the asthenosphere, reacts to the addition or removal of load in its surface. If a large mass is removed through weathering and erosion or melting of large ice sheet glaciers, uplift takes place. On the other hand, areas which receive large deposits of sediments like valleys and bodies of water tend to become even lower in elevation because of isostatic subsidence. And lastly, change in season. It has an effect on clays, which are types of mineral that have absorptive property. During wet season, clays in the soil tend to expand, but during the dry season, these shrink again. This happens over the entire area covered with significant amount of clay soil and causes the ground to expand and contract alternatingly. Effects of ground subsidence. Due to its slow rate, subsidence may not have the terrifying effects of other natural disasters like volcanic eruption and earthquakes, but its effect may last for a long period of time. Sudden ground collapse events can be catastrophic, but are usually isolated and very limited in expanse. Slow subsidence can proceed almost unnoticeably, but may still cause serious widespread damage to property. Mitigating subsidence-related hazards. Examples are: map out the areas which are subsidence-prone and to either avoid development in the area or adapt by modifying or strengthening structures. Areas which experience subsidence are prone to severe, extensive, and prolonged flooding, so structures and roads, for instance, could be elevated. And lastly, dikes and pumping or drainage systems can also be constructed. Effects of ground subsidence. Due to its slow rate, subsidence may not have the terrifying effects of other natural disasters like volcanic eruption and earthquakes, but its effect may last for a long period of time. Sudden ground collapse events can be catastrophic, but are usually isolated and very limited in expanse. Slow subsidence can proceed almost unnoticeably, but may still cause serious widespread damage to property.
Thank you, John Carlos. Now, let's hear from Princess Marjorie to explain about coastal erosion.
Coastal erosion. What is coastal erosion? Coastal erosion is the process by which local sea level rise, strong wave action, and coastal flooding, which wear down or carry away rocks, soils, or sand along the coast. Coastal erosion is a natural process which shapes shoreline by wearing away of coastal land or beaches. It is mainly by the impact of waves along the shoreline. Coastal erosion, as I said, coastal erosion is the loss of coastal land due to the net removal of sediments or bedrock from the shoreline. So coast is defined as the area where land meets the ocean or the sea. What are the four types of coastal erosion? The four types of coastal erosion are corrosion, abrasion, attrition, and corrosion. So, let's define first the corrosion. Corrosion is when waves pick up the beach material, for example the pebbles, and hurl them at the base of the cliff. So the second type is the abrasion. Abrasion occurs as breaking waves which contain sand and larger fragments erodes the shoreline or the headland. It is commonly known as the sandpaper effect. When the wave hit the base of the cliff, air is compressed into cracks. When the wave retreats, the air rushes out of the gap. Often, this causes cliff material to break away. This process is also known as hydraulic action. So the third type of coastal erosion is attrition. Attrition is when waves cause rocks and pebbles to bump into each other and break up. So that is the third type of coastal erosion. So we're moving to the last type of coastal erosion, which is the corrosion. Corrosion or solution is when a certain types of cliff erode as a result of weak acids. So that is the four types of coastal erosion.
Hello everyone. In this video we're going to be looking at erosional processes. These processes occur both along the coastline and also in rivers. They're exactly the same, so you don't need to double learn them. Now, in this case we're going to be looking at them occurring along a coast and coming into contact with a cliff. So when the waves come in and they hit a cliff, and I've drawn the cliff over here and also the waves, the first type of erosional process that you get is called abrasion. This is tiny little particles that are found inside the wave, and they hit and they collide with the base of the cliff and they cause a wave cut notch to appear. It's kind of like sandblasting. Number two, this one is attrition. In attrition you have these jagged large rocks that they roll and they collide with each other, and what happens is that they knock off the rough edges and they become smaller and they get eroded down. This is attrition. Number three, we have hydraulic action. Hydraulic action is actually the force of the wave and does two things. The force of the wave comes into contact with the cliff, and the repeated hitting against the cliff causes erosion because of the energy that it has, and in addition to that it will also hit these gaps they have inside the cliff, and it will push air inside, compressing it, expanding the crack and enhancing the weakness. So, quick recap. As you can see at the bottom, I'm writing down what these are very briefly. Abrasion is small particles that are thrown against the cliff. Attrition is the wearing down of rocks to become smaller and rounder. Hydraulic action is all about the force of the wave and the compression of the air inside various weaknesses and cracks. And there is one more. Solution. Can't really draw this one unfortunately on the diagram. It's literally the dissolving of rock due to kind of like the mild acidic properties that water have.
Causes of coastal erosion. Coastal erosion is typically driven by the action of waves and currents, storms, and strong winds. With climate change, the warmer temperatures cause extreme weather conditions such as stronger storms and higher sea levels. Another cause that causes coastal erosion is us. Humans can also be considered as agents in speeding up the process and intensifying the effects of coastal erosion. So, here is the list of the ways by which humans accelerate coastal erosion processes. First is the removal of vegetation cover, exposing the sediment to wind and water action. The second one is the concentration of drainage water flow into the sea, causing erosion of that part of the coast. Number 3, construction of structures including coastal erosion control structures that interfere with the natural flow of coastal materials, causing erosion in adjacent area of the shore. Number 4 is building activities. Building activities that damage natural protective features. Number 5. Activities which destroy natural protective features such as dunes and vegetation cover. And the last one is number 6, which is the shipping of boating activities producing extra wave action. What are the effects of coastal erosion? Coastal erosion creates and continuously modifies the different landforms of the transitional sedimentary environment. The plants and wildlife that depend on these ecosystems are negatively impacted by the effects of erosion. Economically, loss of these ecosystems leaves coastal areas more vulnerable to damages from tropical storms and storm surges. Coastal erosion results in damage to infrastructures, fishing industries that are dependent on coastal habitats, which can suffer great economic impacts from changes caused by coastal erosion, and the loss of tourism that can result in similar repercussions. These are the specific measures that can be taken to prevent and reduce the coastal erosion. First is the preservation and restriction of activities and development in natural protective features. For example, dunes and beaches. Bullet number 2. Regulating coastal erosion protection structures to ensure that natural protective features are not damaged. Bullet number 3. Prohibiting construction in areas of active coastal erosion and in areas within reach of coastal storms. Bullet number 4. Restricting development of public utilities in areas prone to coastal erosion to discourage new development in these areas. Bullet number 5. Building coastal erosion protection structures only when and where necessary to prevent loss of lives and property. Thanks for listening, and I hope you learned something.